Good morning to all of you. I welcome you to this session on RDBMS. In today's session, we are going to discuss about database management system, about its components, about the three-level architecture for a DBMS. We'll also be discussing something about DDL, DML, and DCL statements. We'll also work around with advantages and disadvantages for a DBMS. And then in our SQL part, we'll be discussing about the constraints that can be put on columns of a table. Okay, that would be the outline of today's lecture. So let's begin. So what do we understand by components of a DBMS? That means like what a DBMS is made up of, right? So a DBMS is made up of the following four components: data, hardware, software, and users. Okay. So these four components would help you to work around with your data within a database management system. Now, data is obviously the most important component. You know, all the things that we are doing to just manage and maintain this data. Two characteristics should be there while you're working with data in a DBMS. It should have two characteristics. Number one, it should be integrated. Number two, it should be shared. Okay. So when we talk of a database management system, we are thinking about a centralized location for data. You know, data is located at a central place and it can be used by multiple users, whether they are in one building, whether they are in one city, or whether they are in one country, right? Like this. Okay, it can be shared anywhere. That is one component. And data should be integrated. Integrated further consists of two things. Number one, data should be valid. Number two, it should be consistent. Now, valid simply would mean that we should not be having anything in the data, like any sort of data. We should have data which should have some valid constraints on it, some conditions on it. Like for example, if we are maintaining employee database, right, and the age column is there, and if you put the age as 200, that is an invalid value, right? So there should be proper constraints on the data. So data should be valid. And by consistency, we mean that similar data should have similar values at different places. The definition of consistency is similar data should have similar values at different places. If we talk of inconsistent data, it means similar data having different values at different places. Now, prior to this database management systems, we had the concept of files. Like you have worked with your projects, your applications in C++, and if you remember, you stored all your data in the shape of files. Now, files, they are difficult to manage. They are not organized properly. If you add something to a file, the previous data gets invalid, right? So you've seen all sorts of difficulties with the files that you've worked with. Now, imagine a scenario where there is no database management system. Imagine an office, okay, an organization which is maintaining record of its employees, and say there is, let's take an example of our college itself. For example, if you are the students and data is being maintained for you, then some data is maintained by your department, some by the main office, some by the accounts office, some by the sports department. So if they are keeping different files to manage your data, then all the data should be updated. You know, similar information about you should be visible at all these places. Say, for example, if Rudra is there in CSC, and he stays at, say, Lawrence Road. I'm taking an example, right? He stays at Lawrence Road. So this fact that Rudra is staying at Lawrence Road is being maintained by all the departments, by CSC department, by sports department, by main office, by accounts office. Let's say now that Rudra shifts to, say, Ranikabad from Lawrence Road, right? So he'll give an application to the department that I have shifted my residence. He'll give this to the department and to say to the accounts office. So at these two places, Rudra now stays at Ranikabad. And if these departments are not coordinated, then maybe in the accounts office and in the sports department, he still stays at Lawrence Road. So this we say is inconsistent data. That is similar data having different values at different places. So while we are using data in a database management system, it should be consistent and valid. Both these things put together would mean that data is integrated. And another important property is that data should be shared. That is, we should be using a centralized location for a database so that all the users can use it, and we have all these validity and consistency constraints properly in there. Next component is the hardware component. Obviously, without hardware, we cannot work. But by hardware, we would mean the physical parts of a computer system, right? So it is required because we need to store data, we need to retrieve data, maybe we need to retrieve data over a network. So all the hardware that is required to manage all these things, whether it is your network cables, whether it is your network connectors, whether it's a switch, okay, whether the internet is there, whether the printer is there to print the information, hard disk is there, okay. So all these things constitute the hardware part, and it is a very essential part of a database management system. Next comes the software, okay, because if you need to manage this data, there should be some provision for, you know, all those storage and retrieval commands and the display commands, the insertion deletion commands. So there should be some software to work with this, okay. So a software would be a group of programs which would help to do all the operations related to a database, right? So right from the 1980s onwards, you've got a large number of databases. Currently, like we are using Oracle, but we had this DBase, the Foxbase, the FoxPro, Oracle, Sybase, Ingress, DB2, Microsoft SQL Server, MySQL. So many databases are there. Okay, so these are all the software part of your database management system, right? So currently we are working on Oracle, you know that, because it's a very stable database, it's a very secure database. The last in the components category is the users category, because you see, you may have data, you may have hardware, you may have software, but ultimately it's the users which are going to use this data. Now these users of a database management system, they fall into various categories, right? They fall into the various categories. Now these categories would be, some of the users would be naive users, right? Naive means inexperienced, like who don't have much exposure to a database. Then some of them would be online users. Online users would mean the users who have learned some commands to work with the database, like they know how to store the data, how to insert, how to delete. So all of you would fall into this online users category. Then we have application programmers, okay? A certain category of users who are designing the applications for your database. Then we have the data entry operators. See, data entry operators are some, persons who are having a good typing speed. Okay, they may not be aware of the existence of the database or how the database works, but they have got a good typing speed. Okay, then the most important category of the user is the database administrator or the DBA. Okay, and this DBA would be like the custodian of the database. We say that is the owner of the database, and he's entrusted with many tasks of the database. So we'll be discussing the responsibilities of DBA in today's session itself. So this is regarding the components of a DBMS. Okay, I hope this particular part of the topic is clear to you. So let's now discuss another thing for a database management system. That is the three-level architecture for a DBMS. That means now we are going to learn what is the architecture for a DBMS. Okay, so you see the generalized architecture of a database system is known as the NSI Spark model. Okay, NSI, as we all know, is the American National Standards Institute, and this Spark was a special committee, the Standards Planning and Requirements Committee, which was set up to pick up this architecture. Okay, and it was proposed in 1975. Okay, and this model is not a standard formal standard or a standard format, right? So, but then it is used by many companies around the world, right? So we'll be studying this. This is what your DBMS for most of the products looks like, the three-level architecture, right? So this architecture is divided into three levels. That is why we call it the 3-level architecture. Okay. At the first level is the external level. Then we have a conceptual level. Then we have a internal level, right? External level, conceptual level, and internal level. So let's have a look at these levels. So at the external level is all the user view. This is the external level, like where you people are sitting. So if you're using a database, then you are at the external level as users. So we have got multiple users here, say user A, user B, user C. Every user is having his own view or schema. Okay, there are some terms which you will understand slowly, right? So pick up this one term today, schema. Okay, so schema is like what all user A wishes to see from the database. Similarly, user B has a schema, user C has a schema. Okay, this comes at the external level. All right. Then at the conceptual level is your database. Okay, at the conceptual level is your database, and at the internal level or the internal view, we have all the physical storage medium, like where all your database is stored physically, like all the files, the structures that is used to store the data, that is at the internal level. Okay. So how these different levels they communicate with each other. So this is done automatically by this mapping is provided by a DBMS or the OS. So the software which you are using or the operating system that you are using, both of them combined together provide you a mechanism so that you as users can interact, can give your requests to the conceptual view. That request could be for seeking some data, inserting some information, deleting some information. So at this level, at the conceptual level, your request is forwarded to this internal view from where the relevant data is picked up and is given back to you. Okay. So similarly, there is a mapping between the conceptual view and the internal view. And that mapping again is provided by our database management system or the operating system. So these 3 levels and 2 mappings, they provide you something known as a data independence. Okay. And there are 2 categories of data independence. One is the physical data independence and one is the logical data independence, right? So 2 levels of data independence are there, the physical data independence and the logical data independence. So let's first discuss the physical data independence. Physical data independence simply means that you can store your data in any physical medium. Like if you are keeping your data at a location A, okay, if you shift it to some other location B, there won't be any problem with the management of the data. So that is what physical data independence means. It doesn't mean that your data should be at one particular location only then it would be accessible. It could be at any location. So physical storage medium does not make any problems with the retrieval of data. Now to understand the logical data independence, you see, like if you were using the files in C++ and you stored the roll number and name in the file, right? So you created a file and stored roll number and name. At a later stage, if you needed to store marks also in that file, you need to create a new file because that file is structured just to hold 2 things, your roll number and name, right? But the same problem here does not exist. That means if you are having some 5 fields in a table, okay, and all the users want to view those fields, then they can do it. Now, if you remove some fields from the table or if you add some fields into the table, that would not hamper any of the views, right? So I repeat again, if you have a table with say 5 columns to begin with, okay, you can view that data, you can manage that data. Now, let's suppose that out of those 5 columns, I remove 2 columns, okay. That would not, give us any problem. Now, the users can still continue doing with the 3 columns that we have. And at a later stage, we may add some 4 or 5 more columns. So there is no problem with the management, the retrieval and the manipulation of data. That is what is understood by this logical data independence, right? So let me just open up some content for you. Let's see if we have got something. So let's just have a quick recap of things that we have learned, right? So first, the definition of a DBMS, right, is a software system that allows access to data contained in a database. Its objective is to provide a convenient and effective method of defining, storing, and retrieving the information stored in the database, right? Then some terms are there. What is a database? What is data? You can just have a look at all these things, right? Now, why do we require a DBMS? Right, this question was asked in today's session by one of the students. Why do we require a DBMS? So we can create databases, we can manipulate the database, we can do some processing and sharing. Okay. Then the protection or the security measures are there. Okay. We can present and visualize our data with the help of the database. Right. Some examples of databases. So this we discussed today, components of DBMS. So obviously it is made of 4 components: the data, hardware, software, and users. So data is a storehouse for data. It should be consistent and valid. That means integrated. It should be shared, right? Hardware would be the physical parts of the computer system. The examples of the various softwares for the database management systems over the period of time. Okay. So just a partial list. There are many other, right? Then the different categories of users we have learned, like the inexperienced users, the online users, the application programmers, the data entry operators, the database administrator. There is another category, database designers. There could be some sophisticated users also, like a business analyst, engineer, scientists, etc. Okay. Then we discuss the architecture for a DBMS. Okay, so we discussed there are 3 levels. Okay. The 3-level architecture diagram. So the external level is at the highest level of database abstraction. Right, you agree that you can see all the things from there, from the external level. You cannot say the same for the internal level or the internal view. Okay. So at each of these levels, the external level, the conceptual level, and the internal level, whatever you see is taken up as a view. So we say that whatever users are viewing here, that is the external view. How the database is being perceived here is the conceptual view. How the database is being stored here is the internal view. Okay. So at the external level, it's the highest level of database abstraction, where only those portions of the database of concern to a user are included. So you see, what is the meaning of this point is that we may be having a large database here, a large table having some hundreds of columns. Okay. But maybe the user A is interested to work with only 5-6 columns, right? User B wants to work with some other columns. So there's an abstraction of view. We cannot see the entire database here. Okay. And maybe these users have been given some privileges so that they can only watch certain portions of the database. That is what the security is. Every user is not allocated all the columns that he can view all the columns from there. Okay. We'll discuss how we can manage this thing. That means how we can give rights to the users so that they cannot view everything from the table, but certain portions of the table. Okay. So users are at the external level. Okay. And each external view is described by means of a scheme called an external schema. Okay. The word schema comes as the plural of this word scheme. Okay. So what is a scheme? Scheme is simply a plan. For example, user A here wants to view some columns, or he wants to update some column, or he wants to delete some rows. So that is his plan. Okay, that is his plan. We call it, that is his schema, right? Similarly, the view B or the user B could have some different schema. Okay, so each external view is described by means of a schema, and that is the external schema. Okay. So what is there? It might be having some description of the logical records, okay, or it might be telling us how to derive the objects in the external view from the objects in the conceptual view. That means what sort of commands can be given so that data can be requested from the conceptual view. All right. Then a conceptual view or global view. Okay. Why do we say that this conceptual view is the global view? Because it is a sum total of all the views at the external level. Whatever requirement is there for any of the users at the external level, that is taken up by this conceptual view. So we also call it the global view or the community view also. Okay, right? And then the internal view is at the lowest level of abstraction. You cannot see much into it, and it is closest to the physical storage methods used. Okay, and it indicates how the data will be stored and describes the data structures and how to access those data, right? And this internal view is described or expressed by the internal schema, which contains the definitions of the stored records, the methods of representing data fields, and the access aids used. So this line means that how to store the records, how to represent the various data fields, and how what method should be there, what data structure should be used to retrieve back the data to the users. Then I discussed with you that with these three levels comes two mappings. Okay, one mapping is between external and conceptual, and one mapping is between the conceptual and internal. Okay, you can see those mappings here. A mapping between an external and conceptual views gives the correspondence among the records and relationships of the external and conceptual views. Okay, so we can say that the external view is an abstraction of the conceptual view, which in turn is an abstraction of the internal view. Simply put, you can just understand this thing like this, that when some request is given by this external view to the conceptual view, okay, it is taken care by either the database management system or the operating system, that this request is received and properly addressed by this conceptual view, which further gives a request to the internal view to bring back the requested data so that it can be shown to the various users at the external view, right? Then comes the concept of data independence. So there is a short definition for data independence. It is the immunity of applications to change in storage, structure, and access strategy, right? You got my point? That means you can change the storage structures. Nothing would happen to your application programs. And you can also change your access strategy. You may be requesting 5 columns. If there are 3 columns now, 2 columns have been removed, still you can request them. So it is the immunity of applications to change, number one, in storage structure, that would be the physical data independence. And then the access strategy, that would be the logical data independence. So the definitions you can see for this physical and the logical data independence, right? So I'll be sharing this file with you. You can just go ahead with it, but kindly understand the importance of this. This is how your database management system works, how you're working with, how you are communicating with your database management system, right? So data independence is there. Next, I discussed with you among the various users, there is an important user known as the DBA, who is also the custodian of the data. Okay, he's the caretaker, he's the owner, and he controls the database structure. Okay, so whenever we are designing some database for an organization, so a database would be a combination of many tables. So whenever we are designing a database for a organization, this person would be responsible in making it and then controlling it later on, like maybe making some changes to it as per the user requirements. Okay, so he is the person, the DBA is a person who is responsible for definition and implementation at the internal level. That means how the data would be stored, he is the person who would see that. Okay, then how the different mappings are there, that would be given by the DBA. Different permissions about who can use what portion of the data is also given by the DBA. Okay, then DBA is responsible for defining recovery procedure. Like if there is some problem with your database, if there is some failure, DBA is the person who would be recovering the data, right? And is also there for maintaining the integrity of the data. By integrity, we would mean that data is valid and consistent. So all the constraints which need to be put on the database is done by the DBA. And his task is also to continuously interact with the users of the organization to see if there is any problem. And if there is some changes required, then it is the DBA who monitors and makes the necessary changes. So important one, responsibilities of a DBA. Then next, what are the advantages of using a DBMS? Okay, So one of the main advantages is that you can have a centralized control over data. Okay. Then next is reduction of redundancies. Important one. So what is redundancy? Redundancy means repetition. Okay. Redundancy means repetition. So when we are maintaining data in shape of files, like we do in the physical files in different offices of an organization, then similar information gets repeated at multiple places. Okay. So that is known as a redundancy. So when we work with a database, okay, when we work with a database, then there is a reduction in the redundancy. Okay. There is a reduction in the redundancy. We cannot say that we can eliminate redundancy completely. Okay. Some redundancy stays there even when you use a database. That I'll discuss in the lab session. Okay. So redundancy would be there, but a little one. And if you don't use a database, then there is a lot of redundancy. Then database management system gives you access to share data, like multiple users can share the data, and the integrity of the data is there. That means you can put constraints on your data. Then security of the data is there. Okay, different security mechanisms can be put so that we can ensure that only the right people get the right access to the right data. Okay, see the sentence here. The right people, that means the authorized people who have been given the authority to use the data, they get the right access to the right data. That means they should not be working with the entire data at all times. Whatever data privilege they have been provided, they can work with that. Okay. Then conflict resolution is there because the database is being used by multiple users. Okay. The DBA can make some changes so that the users, they don't come into conflict with one another. Then data independence is provided by the database management system. Then backup and recovery services are there. Okay. And we can provide multiple interfaces to different classes of users. We can represent complex relationships among data. We can enforce integrity constraints. We can put some constraints. And we can draw some inferences and actions using those rules. Now, we can have disadvantages of a database management system also. The biggest disadvantage is cost. So whenever you are trying to implement a database management system, you need to pick up a lot of hardware items, software, users, the DBA, all these are, incurring a lot of cost. Okay. That is one disadvantage is if you see, and you can see all the things, hardware is there, the software is there. Okay. And efficiency also gets reduced at time because a lot of time is spent in implementing security, integrity, and sharing of data. Okay. And if you say that lack of duplication, we go with the lesser redundancy, then we need to back up the data frequently. So backing up of data is also an expensive operation. Okay. Right. So this is regarding the disadvantages of a database management system. So next I'll shift to the SQL portion. Okay. And in SQL today, I'll be discussing the constraints in SQL. Okay. So I've started a SQL session for all of you, and I'll be logging in as the Spot user so that I have access to certain tables. Right. Okay. And let's first describe the tables, the emp table and the department table. Okay. So you can see here why I've described them. You can see here that emp number, there is something written as a not null here. Okay. So there are null values. That means no value is there or the value is not available. And there would be a not null. So that would mean that while you are inserting information for any employee, you cannot keep this emp number as null. Okay. That is a constraint. Remember, that is a constraint here. Okay. So how we can put all these constraints, because this table is already created by the user Scott for these tables. So if we create our own table, how we can put constraints on it. Okay. So first of all, understand that there are two types of constraints, which are known as the column constraints and the table constraints. Okay. Two things I'm using first, the column constraints and the table constraints, right? So first of all, what is a constraint? Constraint is any condition which is put on any column or columns of a table. So if you put any condition for the data to be entered in a column, okay, and you put that condition on a single column, that is known as a column constraint. Kindly listen very carefully and note it down. If you put any constraint or any condition on a single column of a table, then it is known as a column constraint. And if you put that condition on multiple columns, then that would be known as a table constraint. Okay, that would be known as a table constraint. This distinction should be clear to you, right? Then we have got different types of column constraints. You can just note them down. So I'm now going to list the column constraints. Okay, we're listing them here. One is the primary key constraint, then the not null constraint, the check constraint, then the unique constraint. These are the names of the constraints that you can put. Okay, the unique constraint, the default constraint, and the references constraint. Right? 6 column constraints you can have. Okay. When put on multiple columns, they become table constraints. So there should not be any confusion regarding that. Okay. The primary key, the not null, check, unique, default, and references. These are the 6 types of constraints, column constraints, right? Now, what is a primary key? So if you put a primary key constraint, it looks like this. This is the primary key constraint. So when you have a primary key constraint, 2 things should be implemented in that. Okay. In a primary key constraint, you should have 2 things. Okay. That means the column cannot be left null and it should have unique values. These are the 2 requirements for a primary key. So the moment you put some column, a constraint as primary key, it would not allow you duplicate values in it, and it would not allow you to left those values as blanks. Right? I'm going slow on this. Kindly keep on noting. This would be the technical aspect while you are creating a table. This would be very handy, you see. Okay, so this is the primary key, right? Then obviously not null, you understand. If you put some not null constraint on a column, then while inserting values, you cannot keep that column as blank. You need to enter some value, right? Then you have the unique. Unique again would mean that you cannot put duplicate values into that column, right? So unique would mean no duplicate values. Okay, that is the meaning of this. No duplicate values in the column. Okay. Next we have check. Check is a good one. Check would mean simply that you need to the data which should be entered to adhere to or stick to some condition. So with check, you give some condition in parentheses. Remember, while using the check constraint, you need to give the condition in parentheses. Okay, there could be one condition, there could be multiple conditions with the help of the and or operators, right? So you need to give that condition in parentheses, remember. Then what we have this default, right? So default is if you are not entering, so if you are not entering any value for a column while inserting, it should pick up some default value. I'll just use all these things. So if you are not entering any value for a column, okay, then automatically it should pick up some default value that you have given on your own, right? This is the default constraint. Okay, you can take a snapshot of this screen if you wish. And then I'll be just discussing all of them in detail now, so that you can actually see them working, right? So I'm just clearing the screen here. I'm going to create a table now. Okay, I'll do it slowly. I'll just start with a small table. Then in the lab session today, we'll be just finishing all these constraints and we'll be doing some more work in the lab session. So kindly do attend the lab session. Okay, it should be very interesting today. So one more thing now, I'll show you what I want to say. Create table. Say student. Okay, I'm taking some table student. Okay. Now I would suggest you, I've discussed with you this thing before also, that you should use some editor while doing things. So I'll just enter this command. Okay, and I'll simply write here add. Okay. So while I'm using add, whatever is there in the current buffer will come there in the editor. Okay, this is one way of doing things. Editor gives you an easier way where you can copy and paste things. Okay. So I can just use like create table student. I can use role and I can give the data type as number and I can give the constraint as primary key. Okay. Then I can take name, varchar to 20 and I can give the constraint as unique. Okay, keep on noting. I'll go in small steps, right? And I told you while you are using some editor, don't put a semicolon there, otherwise it will give you an error. So I'm just creating a table student with two columns, role of type number and constraint I have put. This is a constraint which I have put, remember this, right? This is the constraint. So how we go? Column name, its data type, and then the constraint. Column name, data type, and then the constraint. So I put a unique constraint on name. So I cannot give similar names. I have put a primary key constraint on roll number. That means I cannot give duplicate roll numbers. And while entering values, I cannot leave this column as blank, right? So let's have a look here. To run this, simply press a slash here. Okay, so this table is already created. Okay, fine. Let's change the name. Add again. Say I can use this name, right? So the table is created. You can see now this table. I'm describing it. You can see here this not null now. This means that this is a primary key constraint that you have put. Okay, let's try this. Insert into. So let me give the values as 101 and Ajay, right? So this would be done. Let me just change it again now. Say 101 again, and let me do here Sanjay. Note carefully, I'm using the same roll number. But since I have a primary key constraint, it won't allow you to enter this value because the roll number, same roll number cannot be entered, right? Okay. Let's try it again. Look carefully. Let me make it 102 and the same name Ajay. Okay. So remember on this, I have put a unique constraint if you see here, right? So let's see how it behaves. Again, it is the unique constraint is violated. See, there is some names for these constraints. I did not give any names. Let's be very clear about it. This name comes here, sys underscore c. This name comes there. This is the name of the constraint. Okay. Important thing. Look here. Suppose I want to drop this constraint. Okay. The details in today's lab session. But suppose I want to drop this constraint, right? Then how should I do it? I don't have any name for this constraint. Simply the unique constraint has been put. There is no name. So to drop a constraint, we should know the name of the constraint. One thing, right? Okay. And if we have not given a name on our own, then the Oracle engine, listen carefully, if we have not given a name to a constraint, then the Oracle engine automatically provides a name. You can see both the names here. The name given to the primary key constraint is sys underscore c and some number. Similarly to the unique constraint is this. Okay. So if you don't provide a name, then a constraint of type this is a name of type this is given sys underscore c n, where n is a 6-digit number. Remember this. Okay. N is a 6-digit number. Okay. N is a 6-digit number. Okay. Right. Now, if I want to give a name on my own, that should be also allowed. Okay. So I'll just copy this information from here. And open the editor. I'll just paste it here, right? So now I can take a name as stud1. Okay. I don't give a name to primary key. I'll tell you why. Okay. I can give a name to this. Okay. How to give this constraint a name on your own? Kindly note it carefully. So we write here constraint. So this is the way. See, first the keyword constraint is written, then the name of the constraint should be given, then the constraint itself should be given. Note it carefully. I've given this constraint the name as un underscore. So that is a standard way of giving. You can give any name here, but UN would mean that this is a unique constraint. Primary key, we don't give the name because there is only one primary key in a table. Okay, so we'll just work with them in the lab session today. Okay, we just rectify this thing since I've copied it here. Okay, so now I've given a name to this unique constraint. This is the name that I've given on my own. How to give it? After the data type, first write the keyword constraint, then pick up any name that you would like for this constraint, and then write the constraint itself. That is a unique constraint, right? So let's create this table. The table is created. Let's put some values into this table. Okay. Get this copied here. Let's see if it works. Yeah, I can make it. Table name is stud1, right? So this is row is created. Now I'll do the same thing here. I'll put it 102 and Ajay. And remember, on Ajay, I cannot give duplicate names. So now it should tell you that this constraint has been violated. UN underscore name. Kindly check on screen. The name has come up now. Okay. Right. So if you provide a name on your own, then it's okay. If you don't provide a name, then a name of the format sys underscore cn, where n is a 6-digit number, is given by the Oracle engine itself. Okay. So the next question would be like when we created this table. Okay. And I was not aware of this name. Okay. I'm still not aware of this name. If I need to drop this constraint, how we can do it? How I can find this name? Now it has come up automatically here, like this name and this name. Okay. But how we can find that which constraint has got which system defined name? If you don't name it on your own, that we will work with in today's lab sessions, right? So understood this, the primary key and the unique constraints. Let's now work with a check constraint. Okay. Right now I'll be creating a lot of tables because you people are not aware of the alter table command. In the lab session, I'll be just creating one table and altering it to suit our different requirements so that we can learn all the constraints, right? So I will create table, say AA, okay. And then I can just add it here, write this. This I can write here, create table AA, and then I can pick up some role. Okay, put it as primary key. Then I can put up the marks number. Then I can put a constraint here. Okay, check the condition here. Marks is less than 100. So this is my check constraint, right? So what I've done here, there is a marks column, and I'm putting some condition on it. What is that? I'm using check the condition in parentheses. So now the marks should always be less than 100. If you try to put more than 100 marks, okay, then it should be giving you some error. Okay, and I'm not given any name to this constraint, right? So let's create this table AA. Let's try to insert a value here. Okay, so the values are roll number, say 202, and say marks is 88. Okay, just fine with this. If you want to give the marks as 102, it will say that this constraint is violated. The check constraint is violated. Now it is telling you that. And what is the name for this constraint? This. In the evening session, I'll discuss with you how to locate this constraint using the data dictionary concept. Okay. So the information about the constraints would be a metadata, like we have put some constraint on a column. We don't know the name. What is the name? How it should be handled? That would be the metadata for this particular constraint, right? So that's all for today's session, and I think you've understood the concept of the constraints, the 3-level architecture, the components of a DBMS. And in lab session today, we'll be working in a greater detail with our constraints, right? And till that time, just keep watching the videos on my channel. Thank you very much.